Good morning, children. Today's class will be the last class for direction cosines and direction ratios. The remaining problems are all very simple. We solved almost all lengthy and difficult problems. So now you may find all these problems very easy. And this is another problem which is different from the earlier problems. This is only problem left out. So find the direction cosines of a line which is perpendicular to the lines whose direction ratios are. So that means in the plane you have two lines whose direction ratios are given. Direction ratios of the first line are 1 minus 1, 2. And the direction ratios of the second line are 2, 1 minus 1. You must find a line which is perpendicular to both of them. And then find its direction cosines like this. So if you see the second problem, second one, it is example 8. So the lines OA and OB. So in that case, in the second problem, it is like this. You have origin OA and OB here. The lines OA extended and OB extended like this. Direction cosines proportional to C. Understand this. Direction cosines are proportional to means these are the direction ratios. So these are A1, B1, C1, A2, B2, C2 like that. They are the direction ratios. Find the direction cosines of the normal to the plane. Normal means perpendicular. So here also you must find the direction cosines of the line perpendicular to OA and OB. So these two come under the same procedure, the same method. So because the second one is solved example, you can just go through from the textbook. First one I'll solve. So how we do is, suppose that ABC, be the direction ratios. First we'll take the direction ratios of the line ABC be the direction ratios of the line which is perpendicular to the lines whose direction ratios are, whose DRs are. We'll name them as A1, B1, C1. Then it is 1 minus 1, 2, whose direction ratios are this, and A2, B2, C2 is equal to 2, 1 minus 1. So we'll take it like this. Now these two are perpendicular. No, the line and this line are perpendicular. So that implies A1 plus B1. These are the direction ratios of a line. That line is perpendicular to this line. We didn't mention any line. So we'll directly write it. A1 plus B1 plus B1 plus C1 is equal to 0, and then A2. These two are again perpendicular. So A2 plus B2 plus C2 is equal to 0. Now substitute the values. A1 means how much? 1. So it is A minus B plus 2C is equal to 0. And the second one, it is A2 means 2. So it is 2A plus B minus C. A plus B minus C is equal to 0. Now you have only two equations and 3 unknowns. So you will get the ratio of these values like this. You can solve by cross multiplication method. A by determinant of this. So minus 1, 1, 2 minus 1 is equal to B by, for B you will write C coordinates, no? 2 minus, you write the coordinates by cross multiplication method. How you solve by cross multiplication method? Same procedure. For A, or else you write the coordinates like this, no? Minus 1, 2, minus 1, 2, and then 1, minus 1. And then here 1, minus 1, 2, and again 1. So I'll write the determinant. B by determinant of 2 minus 1, 1, 2 is equal to C by determinant of 1, 2, minus 1, 1 like this. So you will get a by implies a by 1 minus 2. This is 1 minus 2 minus 1 is equal to b by 1 minus 2 minus 1. 4 plus 1, 5 is equal to c by 1 plus 2, that is 3. So like this, these are the ratios. So you will write, therefore the direction ratios. So actually this implies that a is to b is to c is equal to minus 1 is to 5 is to 3. So that means the DRs of the line are 1 minus 1 of the line are minus 1, 5, 3. These are our ABC, no? We assume that the DRs of the line as ABC. So these are the direction ratios. Now find root of a square plus b square plus c square. So that is root of 1 plus 25 plus 9, root 35. So that means, so therefore the DCs of the required line, the DCs of the line are minus 1 by root 35 and then 5 by root 35 and then 3 by root 35. So like this we do the problem. This problem and this example problem is also similar to this. You can just try. Okay, now next problem. Okay, next problem. Oh, these are all very simple problems. So we'll do example 10. Example 10. This is again a different problem. Show that the lines whose DCs are proportional to whose DCs are proportional to 2, 1, 1, 4, root 3 minus 1, minus root 3 minus 1 are inclined to one another, are inclined to one another at an angle of pi by 3. So they are inclined to one another means what? That is the only point that you have to learn. Otherwise, it is, you can, if the problem is direct, you can easily do the problem. But here he has given like this. The DCs are proportional to means what? They are the direction ratios. DCs are proportional to 2, 1, 1, 4, root 3 minus 1, minus root 3 minus 1 means what? Implies the direction ratios. So the direction ratios of the lines are A1, B1, C1, that is 2, 1, 1, and then A2, B2, C2, that is equal to 4, root 3 minus 1, minus root 3 minus 1. So direction ratios are proportional means they are the direction cosines are proportional means they are the direction ratios. Now they are inclined to one another means angle between them. One is inclined to another at an angle theta, like that. These are the angles. So if theta is the angle between them, then cos theta is equal to, just write the formula A1, A2 plus B1, B2, A1, A2 plus B1, B2 plus C1, C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So now when you substitute and simplify, you will get the value as it is a solved example. And writing the values directly, it is 6 by root 6 into root 24. So you will get 1 by 2 can be written as cos pi by 3. You can substitute the values and simplify. So theta is equal to pi by 3. So the lines are inclined to one another. That means the angle between them. So the lines are inclined to one another. Inclined to one another at an angle of pi by 3, 60 degrees. So like this we do the problem. Now if you see the exercise problems, first one is find the direction ratios of the line joining 2 points. So you know it is just x2 minus x1, y2 minus y1, z2 minus z1. Second problem, he gave the direction ratios, find the direction cosines. So you can just divide each of them by root of 6 minus 6 square plus 2 square plus 3 square, like that. Next, the third one is find the cosine of the angle between the lines whose DCs are given. So in the third problem, you are asked to find the cosine of the angle whose BCs are given. So they are directly the direction cosines. So in the third problem, the solution is you are given direction cosines. No, so let L1, M1, N1. You take them as direction cosines, 1 by root 3 and then 1 by root 3. And then L2, M2, N2 as the second one, 1 by root 2, 1 by root 2 and then 0. So if theta is the angle between them, if theta, let these should be the DCs of the two lines, be the DCs of the two lines. Now we'll write the cos theta. So if theta is the angle between the lines, if theta is the angle between the lines, then cos theta is equal to, you are asked to find cos theta. So just write L1 L2 plus M1 M2 plus N1 N2 is equal to multiply. So 1 by root 6 plus 1 by root 6 plus 0. So that is 2 by root 6. So 2 by root 6 you can further simplify. You can leave it as answer, or else you can further simplify and write as root of 2 into 2 by 6. 2 3s are 6, so root of 2 by 3. Like this also you can write. This is the answer. Don't write cos inverse. You are asked to find cos theta value, cosine of the angle. So you will write, therefore the cosine of the angle between the lines. The cosine of the angle between the lines is root of 2 by 3. So like this we do the problem. Cosine of the angle between the lines is root of 2 by 3. Okay, next problem, again show that the lines whose, there again he gave direction cosines. So same formula. And then second section, second problem, show that the line passing through 2 points is perpendicular to the line passing through another 2 points. 15. Okay, the next problem. Then we'll do this problem. Okay. Sixth problem. First section, sixth problem. O is the origin. O is the origin. P 2, 3, 4 and Q 1, K 1 are points such that OP is perpendicular to OQ. O is the origin. So your question is find K. Find the value of K. Since O is the origin, you write O is equal to 0, 0, 0. P is equal to 2, 3, 4. and then Q is equal to 1K1. So these are the 3 points, and you are given that OP is perpendicular to OQ. So we'll find the DRs are the direction ratios of OP is equal to A1, B1, C1. So what are the direction ratios? 2 minus 0. So that is 2, 3, 4 only. Now we'll find the direction ratios of OQ, because we are given OP and OQ. So OQ means again 1 minus 0, 1, K, 1 only. So name them as A2, B2, C2. Now what is given? You are given that OP is perpendicular to OQ. So that means their product of direction ratio should be equal to 0. So it implies A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Now substitute. So what is A1, A2? 1 into 2. So 2 into 1 plus 3 into K plus 4 into 1 is equal to 0. So that means 3K is equal to 4, 6, minus 6. So K is equal to minus 2. So this is your answer. So like this we do the problem. So K is equal to minus 2. Okay, next problem. Show that the line through 2 points is perpendicular to the line through another 2 points. So only 2 problems are left now. We solved almost all the problems. Okay, second problem, second section, second problem. Show that the line through the points. Show that the line through the points 1, minus 1, 2, and then 3, 4, minus 2 is perpendicular to the line. Is perpendicular to the line through the points. Perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. First you name the points as A, B, C, D and then find their direction ratios and then apply the condition. If it is satisfied, they will be perpendicular. So show that they satisfy the condition and hence they are perpendicular. So let A is equal to 1, minus 1, 2 and then B is equal to 3, 4, minus 2. C is equal to 0, 3, 2. D is equal to 3, 5, 6 like this. Now we'll find the DRs of the line AB. Line passing through A and B. So the DRs of the line AB are what are they? X2 minus X1. So the formula is X2 minus X1, Y2 minus Y1, Z2 minus Z1. So we name them as A1, B1, C1. So it is 3 minus 1, that is 2, 4 plus 1, 5 and then minus 4 like this. Now we'll write the direction ratios of the line CD. So again same formula. So 3 minus, so we'll take them as A2, B2, C2. That is 3 minus 0. 3 minus 0 is 3. 5 minus 3, 2. 6, 4 like this. Now we'll find A1, A2 plus B1, B2 plus C1, C2. If it is 0, then they are perpendicular. So when we multiply, it is 2 into 3 plus 5 into 2 minus 4 into 4. So it is 6 plus 10 minus 16, which is equal to 0. So you can say, since A1, A2 plus B1, B2 plus C1, C2 is equal to 0, the lines AB and CD, are perpendicular to each other. They are perpendicular to each other. So like this we do the problem. We solve very big lengthy problems. Now these are all very simple when compared to those problems. Okay, next one is find the angle between DC and AB when ABCD are given. Okay, now next problem, second section, third problem. This may be the last problem. So this is second section, third problem. You are given the points as 3, 4, 5. B is 4, 6, 3. And C is -1, 2, 4. And D is 1, 0, 5. The question is find the angle between DC and AB. Find the angle between DC and AB where he has given the points like this. So we'll find the direction angle between AB and DC. So first we'll find AB. The DRs of AB are so x2 minus x1, y2 minus y1, z2 minus z1. That is A1, B1, C1. When you simplify, it is 4 minus 3. That is 1, 2, and then minus 2. So you get like this. Now we'll write the DRs of DC. So DC, B and C. So you can name them as R A2, B2, C2 is equal to DC. Subtract. So -1, -2, and then 2 minus 0, then 4 minus 5, -1. So these are the. So now we must find the angle between them now. So if theta is the angle, in the earlier problem we found cos theta. Now here you have to find the theta. If theta is the angle between the lines, then cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. Substitute. So A1 A2 means -2 plus 4 plus 2 by root of 1 square plus 2 square plus -2 whole square. Again this is -2 whole square plus 2 square plus -1 whole square. Modulus of this. 2 gets cancelled. So it is 4 by 9. Root 9 into root 9 is 9. 4 by 9. So theta is equal to cos inverse of 4 by 9. Therefore the angle between the lines is, theta is equal to cos inverse of 4 by 9. So like this we do the problem. It is cos inverse of 4 by 9. The example problems, you can just see the textbook page 145 and 146. If the direction cosines of a line are proportional to DCs of a line are proportional means they are the direction cosines. So these are the direction cosines. To convert them to direction ratios, you will divide by root of 1 square plus -2 whole square plus 1 square. That is 3, 9. So 4, 5, 6. So it should be root 6. Sorry, the answer it should be plus or minus 1 by root 6 and then -2 by root 6 and 1 by root 6. I wrote the first sum answer. Okay, these are the direction cosines. Okay. Now in this problem C, we solved similar problems. Now PQ and then RS, we solved a parallelogram problem. There we got show that the lines are parallel. So we got the same direction ratios there. So always you prove this way. In the textbook he has done in a different way, and trying to get something common from direction ratios. Like here he has taken 3 common, and here he has taken 9 common, 9 by 2 common, something like that, and made them equal. So you need not do all that. Always first just to find the direction ratios of one side PQ and then RS. Name them as A1, B1, C1, A2, B2, C2, like this. Always first find A1 by A2, B1 by B2, C1 by C2. If all the 3 are equal, then you can directly say that they are parallel. So every time it is not possible, like it may not strike to you to take something common and show that they are equal, something like that. So you can do by this method. So show that A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Then they are parallel. Implies the lines, not the lines. It is the implies PQ and RS are parallel. PQ and RS are parallel. So like this we will conclude. Now fifth example is, for what values of x? For what value of x the line joining? For what value of x the line joining A 4, 1, 2, B 5, x0 is perpendicular to, we solved the OA-OB problem, just is perpendicular to the line, is perpendicular to the line joining C 1, 2, 3 and then D 3, 5, 7. So you just find the DRs of, so you find the DRs of AB, DRs of AB, that is 3 minus 4. You name them as A1, B1, C1. Always you name them as A1, B1, C1. So 5 minus 4 is 1, and then x minus 1, 0 minus 2, that is minus 2. So like this. So you can write the formula x2 minus x1, y2 minus y1, z2 minus z1, like that. So the DRs of CD. CD you name them as A2, B2, C2. So it is 3 minus 1, that is 2, 3, 4. Now since if AB and if the lines AB and CD, if the lines AB and CD are perpendicular, then if they are perpendicular, then always write the condition. In the textbook he has not written the condition, directly he substituted. So always when you are using the formula, write that formula. Then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So multiply 2 into 1, that is 2, plus 3 into x minus 1 plus minus 8 is equal to 0. So that means 2 plus 3x minus 3 minus 8 is equal to 0. So that means 3x is equal to 9. So x is equal to 3. So like this you do. Always write this formula. The formula carries 1 mark. So remaining examples also you can try on page number 146. So with this we completed the chapter. We solved almost all problems, important and expected questions. 2 marks, 4 marks, 7 marks, almost all the questions we solved. So just to practice, you can easily solve the problems in the exam from this chapter. Thank you.